Hey, welcome to another coding session. So today we're going to finish off a bit of this refinement of the grammar. There's just a little bit more that I'd like to do. I don't think it's going to take too long. So another thing that I've been meaning to do that I think is going to help us with our types as values or types as variables, type aliasing, whatever you want to call it, to be able to do this is I want to add a standard library concept, which might seem like totally like irrelevant, like nothing to do with it. But the idea is mainly because we've got all these procedure definitions in here that are hard-coded. And when we make this change for types, one of the things that's going to happen is we're going to have to like redo all this. So just to avoid that, I want to make a standard library which should get rid of a lot of these and make that process a lot easier. Otherwise, it's just going to be a bit tedious. And I want a standard library anyway, so let's see how we go. So the main thing I want to do is take this right-hand side expression and put it up here and replace call. So the statement can be just a right-hand side expression, which in turn could be a call, because that's right-hand side expressions can have calls in them. And then this down here can just be statement, since statement can now be a right-hand side expression. Let me make the change, because then it'll be a bit clearer. So it's like this and this. Another thing that I noticed was there's no such thing as a procedure. No procedure production here anymore. So we just say this is a program is a list of statements. So yeah, statement can be a right-hand side expression. So now in our assignment, if we have a statement here, that means it could be a right-hand side expression. That's why we don't need the or here anymore. So that's the main thing we're going to do. I don't think it's going to be too bad. There might be a couple of gotchas, but mostly I think it's going to be all right. So I think like tokenization, we don't need to do anything. It's parsing where we need to get stuck into it. So this code here is where we did like statement or right-hand side. I'm going to steal that and I'm going to make a parse assignment or right-hand side expression. Like so. So now instead of statement, as the name of the procedure implies, it's an assignment we want to do here. So that's going to be parse assignment. So we need to pass in, we just need the right signature, don't we, basically? Like so. And so instead of appending now, we need to just like return the appropriate node. Like so. And another thing I want to do in here is instead of overwrite, like just throwing in this not very helpful error message, if they both fail, I want to check which one got furthest, and whichever one, we're still returning false, of course. I guess in any case, we're going to return false. But yeah, this is basically it. I want to assign the stream to be whichever stream got the furthest in the parsing, which means that it will also take on the error from there. So we should get the correct error message from these parsers. Should trickle up. That should be much better, I think. So now back down in assignment, we don't need all this craziness. Whoops, didn't want to actually get rid of all of that. So now we can just simply parse a statement node. Like so. Yeah, an assignment is very simple now. It's just parse statement. And we have this is the complicated part. And this is going to go up in the parse statement. Where's parse statement? Here's parse statement. So we don't need call or assignment anymore. We're going to cut that out. And it's going to become like the default case. And I think I'm just going to do return. Yeah, I think we can just do return for these. And I kind of want to reorder them because I'm picky. And in the grammar, if comes first. And we don't need this anymore because if we ever do a successful thing, well, if we ever come into any of these cases, we're just going to return, right? So we don't need that actually. Is it going to be happy with that? No, I think it's going to complain. So maybe we'll take this out. So if none of these specific cases were hit, then we try to do an assignment or a right-hand side. Because these two here, it's kind of ambiguous. They could both start with an identifier. It's not so easy to tell like which one we're talking about. That's why you have this complex thing here to try and figure it out. So I think if we look at the changes we made, it was just here and here. So I think that's about it. Then in type checking, we need to do the correct type checking. So I guess we have a default case. We just say that we type check a right-hand side expression. What do we need to put in there? An expected type. So I guess in this case, there is no expected type. And because we have a default case, we don't really need that. But now again, it's probably going to be unhappy. It's so slow. Oh no, this one's not unhappy. Okay, this I can leave it like that. Okay. So now if we go to type check the assignment, I guess it kind of is fine. It's a bunch of checks and preparation. This could also be a type check statement, but we do this check here to make sure that it's a right-hand side expression. So yeah, I think that's fine like that actually. So if we go to generation, generate statement. I guess we don't need this because again we need the default case to be generate expression. What are the parameters for that? We want a destination and a register number. Destination is nothing. I think that's fine. So let's have a look at assignment just to make sure that there's nothing funky in there. Generate assignment. I think that's fine. We're just doing generate expression for the right-hand side because procedures, which are the only things that would not have an expression there, are handled separately. They have generate procedure instead of generate assignment. So I think that's fine. It's not happy. Not happy at all. What's the resolved data type? There's a call. Okay, that does not seem right. And sometimes we can have, yeah, I think this is like an empty destination. So for that, I think what I want to do is, and I think I want to do this with my other enums2 in time, is I'm going to add a none. I'm also going to go lowercase because I don't actually know why I went uppercase. I like to just have everything lowercase, snake case these days. It's my preference. So here I think I'm going to say, what would it be? It would be the destination type is none. Then we're just going to return, because we're saying, the caller of this is saying, I don't have anywhere to put anything. So there's no point in going down here. Like the expression might evaluate, like the expression might just be a call and it might have a return value from that call. But we're saying we don't want to put it anywhere. We don't need it. So there's no need to copy. So I wonder if that might resolve the issue we had. Oh, I need to put a case in here. So I'll just say explicitly you can't do that, because this is for inserting into assembly, but you should never have a none location in assembly. Doesn't make any sense. Yeah, that's happy. Okay, that's good. That's good. Actually, just to play with fire, I'd kind of like to know whether this OpenGL code still works. Yeah. Still got the right FPS. It's all working. That's nice. I was a little bit worried that might not work. So yeah, that was really quick. That took us like 12 minutes. So I'm really happy with this grammar now. There are still like a few little niggly things that I would like to change. The only big thing I would like to change still is how types are handled, but that's a big thing. So we'll do that in another session. But yeah, like I said before, I'd also like to add a standard library. I think that would be nice. And the way I'm going to do that, I think, is, let's just say source, okay. Well, actually it's there. So I'm going to have, every time we do a compile, I'm going to read two files. A standard lib file, which I just hardcode. We'll create this file in a minute. And then a source file. And in order to combine all these tokens together, I think what I'm going to do, I believe it's a dynamic array of, hey Lucy, tokens. I'm just going to pass that in, a pointer to it. So I'm going to make that an argument, so then it will just append whatever tokens it creates. So then we'll basically end up with like one stream of tokens to pass program, which contains our standard library and also our main program. Hey, Lucy. Hey? You always come up when I'm recording. Hey? Here we go. You can come back a little bit later and then I'll give you some more attention. Yeah, so now tokens, I'm saying that that's a parameter. But it's a pointer to it. And we don't have a return type. And that means that since it's a pointer already, we don't need to put these ampersands. There. I think that's it. So now we can create our standard library file. .bang. And we can try moving some stuff over there. So like the assert procedure could go in here. So we'll take it out of here as well. Run that. And that works. So it's referring to the assert now in the standard library. This I to A stuff, and I mean, this is hacky. I want to replace this with something better, the cast. But let's put that in there as well. And it's happy. Great. Those were the easy things to move in, I think. The next thing, and the main reason that I wanted to do this, is like I was saying before, there's all these. So what I want to do is make like a generic like syscall one, and we'll define that here. So that's going to be a procedure with a whole lot of parameters. They're all I64. I think there are 7 of them. 3, 4, 5, 6, 7. And then a return type. Yeah, that'd be the return type, which is also an I64. And I'm going to make this xturn. I'm going to say it's xturn. Yeah, the definition of it I've kind of got here. So we're on x86-64. So the parameters, I think of this as the first parameter, basically. There's racks, and then there's all these other registers, and this is the return, which is also racks. So, and I'm making it xturn because we don't actually need to define this. This already exists, right? Syscall with a certain calling convention, which is similar to, but not the same as, if we go to our call, here's our call. See, this is where we do our regular xturn. So this is handling the C calling convention with these lists of registers. So what I'm going to do, because all these registers, yeah, these are, you pass by register. Syscall also passes by register, but it's a different set of registers. So we're just going to set those up, and then, okay, so let's let's not jump around too much. Let's set these registers properly now. So it's AX. AX DISI DX, DISI DX, those are all the named ones. Yeah. And then there's 10, 8, 9. So the way I did this negative stuff, like this is 8 and this is 9. And then 10, I consider 0. So when we're doing our registers here, our numbered registers, you can see I add 10 to that number that gets passed in. So that's so when we're using numbered registers in our own code, we start from R10 so that we don't conflict with that syscall stuff. So now I'm actually going to bump that up to 11 because we're using R10 for syscall. It kind of sucks that we sort of like bend to the will of these calling conventions, but what's to do? So those will be reduced now, those two, and I just have to work out what makes sense here. So that's going to be -3, -1, -2, I believe. No, R10 will be -1. that's -3. Yeah, because R10 is not in this calling convention. That's why we don't have a -1 up there. Okay, so I think that's right. Then when we go back to our call, where is our call? Here, this is where we do the extern stuff. This is our list for extern. So I'm just going to make one like that, and I'm going to say there's a name node. Yeah, so that's going to tell us the name of the procedure. And if it's syscall, whoops, that's totally the wrong place here. If it's syscall, we're going to use the syscall list. Otherwise, we just use the regular extern list. And this is the numbered one. So then we just use those ones. Now the thing here is that this is assuming that we have 4 named registers. Oh, and we do have 4 named registers. But this is for less than 7. I think I'm just going to make this maybe a little bit clearer. So if it's less than the length of the numbered registers, and this offset will say it's the length of numbered registers. And if it's less than the numbered, oh, sorry, that should be named registers. And if it's less than the numbered and named, then that works. So that should give us the correct calling convention. The one other thing we need to change is down here when we actually call, we need to say if we're dealing with syscall, then we do it a bit differently. You know, you just say syscall. So we don't need a value like that. So it's a special way of calling. Just do syscall and do it instead of doing call something. Okay. So hopefully that works. Hopefully this syscall would work now. So let's try it out. Let's try it out with exit. So if we remove exit, it's code 60, isn't it? No, it doesn't show it here. If we go to generation, yeah, it's code 60. So if we cut that out and we go to our standard library and we say exit is a procedure with an I64 parameter, and the body is syscall, and so we pass in 60 because that's for exit, and then exit code is the first parameter, and then we pass zeros for everything else. I think that's the right number of zeros because we're not concerned with the other parameters. So we do need to actually put this in here as well. No, we don't need to define it in here. Yeah, we don't need to define it in there. We do need to double check actually when we're generating the call, the return, was the return racks? Yeah, it is for extern. Okay, so that's perfect. C and syscall both have the same return register. So hopefully that works. We're not calling exit with that code. So let's comment that out again. And call this code, which calls the exit. And we get exit code 4. Nice. So if we look at the assembly, we should get here we're calling exit. So if we go to the exit definition, where is the exit definition? Yes. Here's the exit definition. So this is doing the syscall. It's doing alignment, stack alignment. I don't know how important that is in this case. But you see it's put 60 into here, and this is passing in a variable, and then it's just put a bunch of zeros and done a syscall. So I think that works well. Hey. Great. So now we can move along and do some more. I think wait for we don't even use anymore, so we'll just ignore that one for now. Lucy, be patient. I think get time of day is another one that the next one we'll try. So get time of day, I should have checked. Oh no, it's in generation. So it's 96. And we need to pass in a pointer to a time val. So get time of day is 96. And the time val is actually like a pointer to 2 I64s. So we should be able to pass that in. And I'm just going to say untyped. Because this is expecting an I64 and we're giving it a pointer to 2 I64s. But a pointer and an I64 are both the same size, so it works. And I think that's it. I think that's get time of day. So that's Xcode 4. So so our FPS counter should still work. Yeah, it still works. That was relying on get time of day. Clone we're going to have to keep here because it's kind of special. It does some like jumps and stuff. But this print stuff we can change. So I want to actually do this in a few steps. So the first thing is to be able to write. With a file descriptor and a message. And I think we're going to have to do this. And make a I64-2, which is the untyped message. I'll explain this in a minute. So 1 is to write. That's the syscall write is code 1. Pass the file descriptor. And so a string object is actually a length and a pointer to the data. And both a length and a pointer are 64-bit values, right? So if I do this, I'm basically assigning to this. It's basically my way of doing type conversion at the moment. It's really hacky, but I'm just saying like ignore the type of this and assign it to something with this type. So now it has this type. But it's exactly the same data, which means that the first thing in here should be the length, which I think needs to go here. And the second thing in here should be the pointer to the data, which needs to go here. So that should do a write. I hope. And then print. Print is simply the same thing. We don't need to put the file descriptor in. And we can just call write with 1 and the message. Because 1 is the file descriptor for standard out. So that's going to print to the console. So that's pretty good, I think. I'm also going to do, we'll also do print line. Why not? So then we're just going to do an extra write with the new line character. And then we're going to do this write B, which takes in a boundless I8. So it's just some bytes, some data, and a length. So then we can just put this directly in here, and this will go in here. Again, we need it untyped because the syscall is expecting an I64 and this is something else. We don't need that. We can just do something like that. So that's write B. And then I want to do a print and print line with B as well. Print B line. These are going to take in this. So it's going to be write B with message and length. Write B with message and length followed by a new line. Yeah. Yeah. So I think that should hopefully work. Okay. So we're getting an issue with the conversion, line 16. Because we're saying here that it's an untyped message. I wonder if we've got, because we already have a directive here. Now we're trying to use another directive. So there's probably some clobbering going on. If we go to type checking. Well, this is somewhere where we do something. So here we're saying, like, if this did not introduce any directives, then go back to the old one. But for this to introduce directives, I think it would be because it has looked up the identifier. Right, so where's our standard lib there? So I think when we're evaluating this, when we evaluate this, it'll look up this identifier, which will give back this type, and that's overriding this with the current way of looking at it. So I think actually a better way is to say, so this one here is like, should have more precedence. Better, this one should take precedence, I think, because that's this one here, which is more like, this is from the previous definition, but here we're saying like, no, this is the directive we want. I think that makes sense. So maybe if that's not empty, we should just take over. Okay, print and print B are getting redefined because I haven't taken this out. Okay. Wait for, I think we just cut that out, right? Yeah, so now we just have syscall and clone. I think that's as good as we're going to get right now. So let's get rid of wait for. And then there's this custom thing here for bounds checking. Cool. Okay. Another thing that would be nice, I think, because we're doing pretty well for time here, we're getting shit done, is that when we have an error, like if I say in standard lib, if I put a hash there, that should throw an error, right? But it doesn't say what file it's in, and that's kind of annoying. Like we have 3 files now, because we always run the tests. We compile the standard lib, we compile the example. So it would be nice to say what file it's in. So I think I want to make like a file info struct. I'm not sure where to put it. We do need to split out into multiple files, but let's just put it here for now. File info. So that's going to have like this line number, column number, and name, the name of the file. And then anywhere where we reference these things, we're just going to reference file info instead. Tokens, AST nodes, do they also have file info? So then anywhere that's like this, we're going to say file info equals file info. So that simplifies things a bit. That's nice. File info, file info. So this guy to this guy. Okay, apparently that's it. I need some fixes in here though. Guess that needs to be that. So we need to say let's just say name. And this is where we maintain them. So I guess we just need to access file info now. I guess here as well. I always like it when it makes code simpler. When I introduce features and code gets simpler, that's like the best. Voila. Okay. There's another one. Okay. Parsing. Oh, parsing still has some issues. I'm sure there was more. Yeah, here we go. Okay. Oh. Why don't you show me all the errors at once? That would be nice. I have to jump around as you give me like one here, one there. And I guess type checking probably has a bunch. Does it? Does it ever refer to the line number? It does. Okay, this is kind of annoying. I think we probably should have some convenience function for printing this out. Yeah, should we do that? So in tokenization, I notice it's here. In main, we also have here. So we need to pass the name in now. So let's say this, and this will be source path. So it'll say failed to pass file %s next token dot file info dot name. So we kind of want maybe alongside this file info like a file error, maybe with a message, and some file info. And that'll just do something like this. Yes, what's up? You want some attention? Hey? Okay, let me pause for a little bit and give this poor cat some attention. Okay, had a break with the kitty cat. Now I have to remember what the hell I was doing. That's right, I wanted to make this file error thing just to kind of cover this. Yeah, because I think we're going to do it in a bunch of places. So for example, in main, we're saying like failed to parse. And then I guess we just pass in the file info. Is that it? Yeah, nice. Okay, and then in tokenization, there was like this, so it's like unclosed string. I guess it should be like unclosed string in. It's like unclosed string in file. I don't like that we have these exit ones, but let's leave that for now. So I guess I kind of want to search for anywhere that we have this. Okay, there we go. Lots of places. So lots in type checking and in tokens. Ah, that is that's my other project. That's Bangalang. Okay, so lots in type checking. So let's do a find there, and then we want to replace all these with file error, I think. So file error. It's kind of okay-ish. I'm not in love with it, but it'll do. Body. And this is the... so this is taking the value as well. Okay, that makes things a little more complicated. Did this take anything else? I don't think so. So then we need to do like a, we can do like a a printf. And we can put the value in there. So that should substitute the value. So I mean, it's like, it's kind of better than what we had before. It's not amazing, to be honest. I don't know that we gained that much from it. You know, we could just update all these to say file info instead. And actually, you know, that's what I'm going to do, because I don't feel like we're getting that much out of this, to be fair. But we do have to add that as well. Okay. Maybe it is worthwhile. And now, we do have this local history. Can I go back to where we had file error? Yeah, let's revert to there. That's quite a handy feature. Okay, so we are going to do this. So we need to get rid of that. It's like the third time I've done this. So this here doesn't have any other substitutions, just like in, and we pass the file info. So that's file error. This one does have a substitution, a print if. So that's file info, and this one we move in here. And that is basically the same. Great. Down here, this is also incompatible types. So that is also the same, right? Nice. Too easy. Okay, so it's invalid type. Not a very nice error message. These are all the same. So they're not nice error messages, but it's making it easy for me to copy and replace at least. Another invalid type. I need to improve these at some point so they actually give, like, really what we're trying to say here is you cannot negate this type that you've given me, instead of just saying, hey, this is an invalid type. But that's what I do everywhere in here, it looks like. Oh, this one actually says out of bounds. That's nice. What about these ones? That's undeclared identifier. And that is wrong number of parameters. So that one does not. But it also has this expected. Oh, but they're in different lines. So I think we can just like go boom, 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 boom. for this one. Okay, and then we go back to these ones. What was difficult about these ones? So let's go file, error, format.aprintf. No, two of those need to be in there. And that needs to be file info. Okay, and this is just another one of these. So is that all of them? Is that everything? Are there any more errors? Can I get on with my life? There we go. So failed to parse file blah 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 at here. Okay, so we know it's in the standard library. So we can go to standard library, but it has the wrong line number. That's interesting. Why would it have the wrong line number? So when we tokenize, we start from scratch for every file. So I don't know why it would be doing that, unless it actually is on this line that it's having an issue. Because it's saying found identifier. I thought it was this hash that was the issue. It was the hash that was the issue, but it was totally giving the wrong error though. That's weird. Like even this doesn't really make sense. Expected identifier found colon, because I added a hash, not a colon. So that would be considered a directive token, I think. Or does a directive token have to have something after it for it to be a directive? That'd definitely be a directive token now, especially if I put a space there. I mean, space shouldn't be needed, but. So I added a directive there and I get an error up here. And it's like talking about something different. Is that, I wonder if that's an issue with our, like when we do our parse, yeah, this or, because I tried to get it right. Is it reporting the wrong error? This is the only place where it reports an error. So if we're talking about a right-hand stream, then I'm not sure why that is. And I don't think I'm going to do anything about it right now. Let's just correct that. And everybody's happy. Oh, I thought I killed the recording there. I hope it's all good. I hope it's all good. Because there was one just little thing. We've got like a little bit of time left, so I thought, you know, why not? Let's do like a little something extra. I'm pretty happy that we've got like a standard library now. We've got error messages that tell us what file we're talking about. We've got our grammars looking really nice. One more thing I just wanted to, I've been talking about this for a while, is to like split the files out a bit. So I think I'm going to start with just like 2 extra files. One of them is just like source, because all of these existing ones, generation, parsing, tokenization, they're all kind of like the you could sort of say like the steps in the in the compiler. I have an architecture thing here. Here we go. So they're the steps, right? It's like tokenization, parsing, type checking, generation. So I'm just going to make a file that's like one for source, one for tokens, one for AST. I don't think I need to make one for assembly, but let's just make those. And they can, yeah, then we can split out just a little bit of code. It's not going to be anything amazing, but it'll be a bit nicer. So I think this rune stream, I'm going to put in source here. We need to put a package. I'm curious because I know my IDE does like this auto detection of the indentation. So I'm wondering if I start a file like this, is it going to continue with two spaces? Because I want 2 spaces. I want 2 spaces, damn it. So let's take that rune stream out and this, all these rune procedures. We put it in source. It looks like it has not. And I also want to just like rename this to, well, maybe, did we cut those out? Yeah, we did cut them out. So since this is the source file, I think I'm just going to rename this to a source stream. Yeah, I think we'll still say peak rune because we're talking about runes, I guess. I guess this is more like peak string or next string, peak string. Yeah. Okay, so now we have all of our source stuff. I think that's all the stuff that's kind of related to source in there. Yeah. So I made a source and an AST. I guess I didn't make tokens. So for tokens, we have like definitely the token struct. And the token stream, yes. Token struct, token stream. Tokenize stays in here, of course, and those read procedures. These are like kind of types of token. So I think I'm going to move them in here. File info kind of is a bit weird that we're just throwing this in here, but that's all right, whatever. Oh, and this type, token type, also. We can put in here. So I think that's all the, yeah, it's a bit weird we have file info in here, but the rest of this is like definitely tokenization now. Let's do, I hope that this works, that by doing this, then my IDE will sort of figure out like, I want 2 spaces. So there's tokens, source. Why do you think I want that? Now AST, I think I defined this in parsing. So that's the first place I use it. So this is the AST, this data type, this. I guess, yeah, there's comparison operators also. And then there's all these procedures that are like parse this, parse that, parse, parse, parse. I guess these utilities could be thought of as like, you know, it's like the utilities could go into the AST stuff. But let's leave them in here for now. Okay, and something I kind of would like to do, I think, is say like binary operators. Because when we go to type checking, and we type check right hand, here we go. There's all of these. So we still have these ones here, which are not in the list. It's got all the comparison ones, but not these. So let's add these. Like so. Then in here we can say, we can do like a slice linear search, node type, and then what does this return again? Index and found. We don't care about the index. It's just like, we want to know if it's a binary operator, and then we can go like that. And then in generation, we do the same thing. Like that. I think that's nicer. That's a nice little improvement. Source tokens. Okay, so we need format. Yeah, we haven't imported anything. Core format, I guess. We don't need to, I mean, we're just defining types here. Like, it makes sense that we don't really need anything extra. Let's change our indenting. Very nice. So that's our AST. So now we're really just like parse, 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 parse. Type checking is really like type check this, type check that. We do have these lists. But they are like lists of types. That's more types. So I'm going to leave that in there. And there's a bunch of, yeah, there's a bunch of just like type utility functions. So I think we could like, eventually we'll split that out and have like a type file. And then generation, yeah, it does have a few structs of its own. It also has these. And it also has a bunch of utilities, but I think that's kind of enough for now. I just wanted to make a start on it. Then eventually for all of these, you know, like parsing, I want to split it out. So it might be a bit overkill even, but just like, you know, I make a program file, a statement file, an if file. So they're going to get quite small. Yeah. But I think it'll save us from a lot of scrolling, and hopefully it's easier. Like I don't necessarily think that having lots of files with small amount of code is easier to navigate than a big file. But let's see. I think that's something that's really interesting with this YouTube. Putting it on YouTube is like, I really want to be as practical as possible. So it makes me really think, like, is this going to be more practical or not? Whereas before I would have just assumed, you know, split it up, it's fine. So I think that's about it, you know, and we've done about an hour. So I'm pretty happy. We did a little bit of tidy up and we got a bunch of new features in. That was a really productive episode. I feel like recently there's been so much like a lot of sessions where I'm just like grinding away and not having a whole lot to show for it. So it's nice to have a session where it's like pow, 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 pow. Yeah, it looks good. Okay, so enough for today. Thanks for stopping by. Have a good one. Ciao for now.